Alright guys, welcome to lesson 1. What we're talking about today is refraction. Now what you need to understand before watching this is that light is an electromagnetic wave. So what we're going to be talking about is light as a wave. Also, that visible light is a range of frequencies. So we'll talk about that now. What you see on your screen is what's called the electromagnetic spectrum. Now a lot of syllables in that, but basically what it is what we call different waves according to their wavelengths. If you start on the right, where we consider things to have long wavelengths, from 1 meter to 1,000 meter wavelength is what we call radio waves. Any smaller than that, we enter microwave area. Any smaller than that, we enter infrared area. Now right here where this rainbow is a sweet spot, what we call visible light. And the frequencies range from 4 times 10 to the 14 hertz to 7 times 10 to the 14 hertz. Any less frequency than that, you're in the infrared area and our eyes can't see it. They're not visible. Any more than 7 times 10 to the 14 hertz, you enter ultraviolet light, and that's light that we cannot see either. So the point of me showing you this is to understand that light is a wave, and based on its wavelength, we can either see it or we cannot see it. Now, moving on. Right here is a picture of a red laser being pointed from air and entering a glass block. Now, up here is where the light is coming from. Okay, I'm just going to draw an arrow for you, if I can figure out where the arrows are. So the light's direction is like this as it comes from air. When it reaches the boundary between this glass block and the air that surrounds it, it no longer goes in the same direction. What happens is that it changes its direction and goes that way. Light enters a new medium. This is now glass. It used to be in air, so the direction changed. Now we could even tell the story a little bit further down here. Light is traveling through glass and enters a new medium as it's exiting into the air again. It was traveling in this direction, but when it entered a new medium, which is the air, it changed its direction. Here, it changes direction upon entering a new medium. Here, it changes direction upon entering a new medium. So, what we'll say is that refraction is when light changes its direction upon entering a new medium. Now, this will be our definition for refraction. It is a scenario where light is changing its direction when it enters a new medium. Alright, right here is a diagram. We need to talk about what we call all the different rays of light so that we can move forward. Let's start with the incident ray. The incident ray is the ray of light that is, you can think of, is the initial ray of light. It's the light that's being pointed at towards the change of mediums. This blue solid line, this vertical blue solid line here, is what's called the normal line. And the reason why it's called the normal line is because in math, normal means perpendicular. It makes a right angle with the boundary. That's why we call it the normal line. So the incident ray is that very first ray. And the angle that the incident ray makes with the normal line is what we're calling the angle of incidence. You'll see it often as theta I. The light that is through the second medium will be called the refracted ray, because this is the ray of light that's being refracted. It's the ray of light that's changing its angle. The angle that makes with the normal line will be called theta R. Incident ray, normal line, refracted ray. The angle between the incident ray and the normal line is theta I. The angle between the normal line and the refracted ray is theta R. Let's play around with a little Phet simulation now. So this is a little Phet simulation. There is a red laser that's being shined. It starts off in water. As you can see, the material here is selected as water. And when the light enters a new medium, which is air, it changes its angle. Now we can read these angles. So the angle of incidence is 30 degrees. The angle of refraction here is 41.8 degrees. What if we were to have air on top and water on the bottom? Let's switch it up and see what happens. So air is on top now and water is on bottom. The angle of incidence is still 30 degrees because I haven't moved my laser yet. but instead of going up to 40 something degrees, it went down to 22.0 degrees. Let's switch it up one more time and see what happens again. Water, air. 30 degrees right here increases to 41.8 degrees. When this angle increases, we're going to say that the refraction is away from the normal line, the dotted line. Switch it up back again to air and water. This is 30 degrees. It's now a smaller angle, 22 degrees. We're going to say that this refraction happened towards the normal line. So right here we're going towards the normal line because the angle got smaller. And over here we're going to say the refraction is away from the normal line because the angle got larger. Alright, let me zoom into this. There are two things happening here. Let's focus on the first image. What's happening is that air is the first medium and glass is the second medium. The incident ray approaches the boundary of the two mediums with an angle theta I and gets refracted. Now this angle is smaller. Theta r is smaller than theta I. You can see it just visually. This is where we say that the angle of refraction or the refraction happens towards the normal line. Now what happens in the second diagram, we switched air and glass. We put the glass on top, we put the air on the bottom. Now the angle of incidence is now smaller than the angle of refraction. What that means is that the refraction happened away from the normal line in this case. Now, why do you think that happens? Well, the reason is the two mediums have different densities. So when moving from a less dense material to a more dense material, the angle of refraction will go towards the normal line. When going from a more dense material to a less dense material, your refraction will happen away from the normal line. Let's zoom out a bit. Feel free to go back to any time in the video to try to answer these questions, but the best thing to do is to try to answer them now. First is, in your own words, define refraction. Second is, when does light refract away from the normal line, and when does it refract towards the normal line? Third, draw a diagram showing the refraction of light for both cases in question 2, and label the incident ray, refracted ray, angle of incidence, and angle of refraction. Once you do that and you're confident, you can continue watching the video because I'm about to show the answers. To summarize what we've talked about, refraction is when light changes its direction upon reaching a new medium. Light will bend away from the normal when going from more dense to less dense mediums, and light will do the opposite when going from less dense to more dense mediums. If you have any questions, leave them in the comments. I'll get to them as soon as I can. Thank you for watching.